Hello everybody, my name is Jonathan Quissis, and today I want to show you how to code in the insertion sort algorithm in Java. So I'm going to go ahead and create a new class here, and I'll call it insertion sort 7. You can't see that, but here it is magically on your screen. So what we need is one helper function to print the array to the console. So I'll go private static void print array, and once again that's going to take an int array, and it's just going to print the items in the array to the console. So int I in array, do a sysout on that one, and we will have the I plus a space on a single line, and then after the for loop just do another sysout. Great. Now let's code the actual algorithm. So I'm going to call this a private static void insertion sort. And of course, it's going to take an integer array called array. Now what we want to do is have one for loop, int I equals 1, not 0, because if we think about it, if we're starting from the 0th element, well, if we're going to sort it on the left side, there's nothing on the left side to sort it with. So we want to start with the first element, so we can compare it with the 0th element. I is less than array.length, make sure it's spaced correctly, and I plus plus. Now what we need are two integers, or up here I should actually declare them, int key and value. And we can set key to equal I. The key will be incremented in a while loop, as we will see. And then value is going to be set to our current value at I. Oh man, did I do that wrong? There we go. Now we need a while loop. While key is greater than 0, we will see why in a second, and value is less than array key minus 1. I believe I did that right. So what we are going to do is we are essentially checking if the element at array I is less than the element before it. And if it is, what we want to do is we want to move that element one spot to the right. So we want array key equals array key minus 1. So that moves the element that is larger to the right. And then we want to go key minus minus. So let me explain this a little bit further. So we go into this while loop. We have an integer, or key is greater than 0, because if key equals 0, means this won't work. Key minus 1 will equal -1, and we'll have an exception. So we have that. And then and value is less than the value before it. So before I show you, we have one more thing to do. Array key simply equals value once that's all said and done. So we'll go public static void our main argument, string args. And I will create an integer array called array, and I'll set that to the worst case, which is a reversed sorted array. Then we will call our helper method print array to print that array out. We will then call insertion sort, since this is an in-place sorting algorithm, this will work. And then we'll finally call the sorted print array. So when I run this, we will see that the result comes out to be 5, 4, 3, 2, 1, 1, 2, 3, 4, 5. Now, since we have an array of 5, 4, 3, 2, 1, that gets passed into insertion sort, that comes up here. And then we start at I equals 1. I equals 1 is 4 down here. So value is array equals I. So value is now equal to 1. While key is greater than 0, well, key is I, so that returns true. And the value, which is 4, is less than array key minus 1. So that'd be 5. That also returns true. So 4 is less than 5. So what we want to do is we want to move 5 into 4's position. And then we want to keep doing that until either the key is less than or equal to 0, or this condition here returns false. And that's what we do here. Key is less than or equal to 0 once we decrement it, and then all we have to do is set array key, so this position here, to 4. So then essentially we would have, let me just write it down here in a comment, instead of 5, 4, 3, 2, 1, on our first paths, we will have 4, 5, 3, 2, 1. And then we will keep doing that. We'll keep iterating. So we will have, we'll check number 3. 3 gets moved because it is less than 5 up here. So 3 here, less than 5, and it's less than 4. So it'll actually be 3, 4, 5, 2, 1 on our essentially third pass or second pass, however you want to count that. And then we do that with 2. 2 keeps moving over and over and over, and 5 moves over, 4 moves over, 3 moves over. Once we hit the beginning of the array, we set number 2 into number 3's spot. And since we moved everything over, it's 2, 3, 4, 5, 1. And then finally, we do that with our last pass. So 1. 1 gets compared to 5. 5 is greater, so that moves over. 4 is greater than 1, so that moves over. 3 is greater than 1, that moves over. 2 is greater than 1, that moves over. And then 1, since we're at the beginning of the array, becomes inserted into the first or 0th element. And then we have our final array. So that is essentially the insertion sort algorithm. I kind of went through that pretty fast, but essentially this is the code. Once again, we have a helper function up here to help print our array to the console, and then the main insertion sort algorithm is right here. So I hope you enjoyed, and I'm Jonathan Quisis. Hope you have a great day.